Welcome to the Scikit Machine Learning Tool tutorial. In this tutorial, we will use Gaussian process regression, or GPR, to model and predict the GPU kernel performance. GPR is a non-parametric Bayesian method that captures uncertainty and structure in the data without requiring a fixed form. We apply this method to a high-dimensional regression problem, where our goal is to predict the average execution time of GPU kernels based on low-level configuration parameters like tile sizes, vector width, and memory access flags. Multivariable regression is used to analyze how multiple independent variables simultaneously influence a continuous outcome. This approach is especially valuable in real-world GPU performance tuning, where many interacting kernel parameters jointly affect runtime. By estimating the marginal contribution of each parameter while accounting for others, multivariable regression offers insights into both performance optimization and feature sensitivity. The dataset used here contains about 5,500 kernel configurations with 14 input parameters and one target. The average kernel runtime in milliseconds, labeled as average run. Each input feature corresponds to a low-level GPU tuning parameter, such as workgroup sizes, vector width, tailing strategies, and memory stride controls. These parameters come from auto-tuning tools and control how kernel interacting with the GPU architecture. The dataset has been pre-processed to ensure that all categorical flags, like SA and SB, which determine scalar versus vector memory access, are represented numerically. All features are now suitable for input into the GPR model. The dataset has been split into 80% for training and 20% for testing, ensuring a robust performance evaluation under realistic generalization conditions. Gaussian process regression models a distribution over functions by defining a mean and covariance kernel. In this project, we use a radial basis function kernel to model nonlinear relationships between kernel parameters and runtime. GPR not only provides a predicted value, but also estimates predictive uncertainty, which is extremely useful when performance tuning under constrained or incomplete knowledge. After training the GPR model on 80% of the data, we will evaluate it on the test dataset using the R-squared metric. A higher R-squared value means a better prediction of the GPU runtime. Now, let's move on to the implementation of the GPR model using our Scikit interface. First, let's name our project here, and then let's give a brief summary of this project. In the data section and the data type drop-down list, let's choose tabular data since our dataset is in CSV format. And then let's click this button to upload our data. After successfully uploading our data, we can see the information of this data on the right side of this page. The Table tab shows all the columns of our dataset, and if we want to have a more detailed information about dataset, we can click Next to view other rows of this data. And then in the Data tab, we can see the null instances, data types, and unique values of this data summary. Now let's go to the pre-processing section and select our target value, which is the average runtime. And then let's select the machine learning algorithm as our method. And then let's select our Gaussian process regression model. And then let's select our evaluation metric, which is the R-squared. And finally, let's click Perform to get a result. After a few seconds of processing, we can see we have the result. The R-squared score is 0.95, which means our model was able to accurately predict the values of the runtime. If we want to see the details of our prediction, we can scroll to the right on the Table tab And then we can see the two columns. The y-test means the ground truth of our data, and y-predict means the predicted values of our data. We can see the predictions are very close. And this has been our tutorial for Gaussian process regression model. Thanks for watching.